You know what's fascinating? We all think circuits are simple until we hit alternating current.
It feels like a whole new set of rules, right? Suddenly, there are all these new terms.
This jumble of formulas is exactly why it feels so overwhelming.
I know that feeling.
We try to use our simple DC logic, but AC, well, it just plays by different rules.
Here's the thing. That's the core misconception, and this one point changes absolutely everything.
Once you see ACC not as a flow, but as a wave, the puzzle pieces start to fit.
So DC is steady. AC, on the other hand, oscillates back and forth, just like a wave.
Phase just asks, are the two waves peaking at the same time, or is one leading the other?
Okay, let's break this down. Each component reacts to this wave in its own unique way.
First, the resistor. It's simple. Voltage and current waves move together, perfectly in sync.
Next up, the inductor. Think of it like it has inertia. It hates any change in current. Because it pushes back, the voltage has to peak first just to get the current moving. Now, here's a simple way to remember this. E-L-I. For an inductor, L, voltage, E, comes before current, I.
And finally, the capacitor. It needs to charge up before the voltage can build across it.
So current has to rush in first to charge it up. This means the current leads the voltage.
And remember our trick? For capacitor C, current I comes before voltage E. That's ice.
So what happens when we put these three opposing personalities into one single circuit?
You can picture it like a battle. The inductor pulls voltage forward, the capacitor pulls it back.
This combined opposition isn't just resistance. It's a new thing we call impedance.
But here's where it gets really interesting. What if their effects canceled each other out perfectly? That perfect balance? Well, it has a name. Resonance. It's a magic frequency for the circuit.
At this one frequency, the inductor and capacitor's opposition just disappears. They cancel out.
So what's the result? The total impedance, Z, drops to its absolute minimum, just the resistance.
And with opposition at its lowest, what happens to the current? It skyrockets. This is how radios work.
So, when you see AC not as formulas, but as a story of waves, the confusion just melts away.